Hi, and welcome to DCO. In these videos, I teach architects, engineers, designers, or those interested in 3D modeling how to use Rhino and Grasshopper to empower their creativity through parametric and 3D design. In this video, I'll go over how to create a structural envelope that involves a wireframe structure with panels and connections, as well as openings. I make sure to go over all of the steps in detail, so please let me know if you have any questions or if you would like something clarified. If you want to gain access to the script that I created in this video, join the Script Vault membership where you'll have access to the script and much more. Otherwise, keep an eye out on the script store where I will have the optimized version of the script so you can download it there. I post videos like this every week, so make sure to subscribe so you don't miss any updates. Thank you very much for being here. Hit the like button if you enjoy this tutorial, and let's jump right in. To start, we're going to first bring in a construct point. So I'll double click here, go here to construct point, and we'll bring in a point at the 0, 0, 0 coordinate. And now we can start by moving that point up, and then we'll move it here in the X direction. So let's start here with this point. Bring in a move component. We'll plug in the point into the geometry, and in the motion, we'll bring in a unit Z. This way, we can move this up in the Z direction. So let's bring in a slider. And so this will determine the height. I'll type in units and see what units we're working here. Now I have millimeters, but I want this to be a large design. So I'll go here and change that to feet. And so that would be 79. Now let's move this top point in the X direction. So I'll go here to a move component. And in the motion, we'll bring in a unit X. For that, I'll also bring a slider, but I like to just copy this one so we can save a little bit of time. And so with these 3 points, now I'll put it together using NURBS curve. Now you could also use interpolated curve or 3-point arc, but in this exercise, I want to show you using NURBS curve. So we'll start by adding the first point, and holding down shift, I'll add the other 2 points, and under degree, I'll change it to 2. This way, the component is running correctly, and when we change it from 2 to 1, it actually changes it into a straight segment. But we do want one whole curve. This way, we can extrude it and have a base surface that we can apply our design to. So let's take our arc and go here to extrude, and we'll be extruding this in the Y direction. We'll go here to Y or unit Y, and we'll also copy a slider from here. That's our extrusion. I'm just moving some of these sliders around just to see the results that we get. Now with this base surface, what I'd like to do is plug this surface into a surface component or a VREP component. Either one would work. And the reason why I do that is because since this is the base geometry, I can also bring in a surface or set a different surface that I create here in Rhino. And this way I can switch between a parametric surface and one that I can create inside of Rhino. Let's clean this up. I'll go here to structure height. Length. Degree. This is going to be length. The cool thing is that I can also turn this into a straight line by having it have no overhang, right? Cool. On this next steps, we're going to be offsetting. We're going to be offsetting this surface, then subdividing it with triangles, and from there we'll continue creating the connections. On this next portion, we need to offset the surface to the outside. This will give us the offset between the inside wireframe and the outside kind of skin. So I'll go here and bring in an offset surface. The distance is going to be to the outside by whatever slider. So let's go here and bring in a slider, say 4. And it's offsetting it to the inside. So if we want to offset it to the opposite direction, we'll go here to a negative component. This way, we have a positive slider and it converts it into a negative value for the distance, which is the direction that we want to offset it. Now that we have this offset, we need to subdivide both of those using whatever pattern you want. For this time, in this time, we are going to be using lunchbox, and then under panels, we'll be using triangle panels B. I'll go ahead and offset this out. Now I'll bring in under lunchbox, triangulated panels, and I'll plug in the original surface. And that's quite a bit of subdivisions. We could probably use a lot less to start with, and then we can increase it later on as we kind of complete the script. Let's go here to U divisions. I'll go to 3, and I'll create 2 sliders here. And I'll disable the preview on the surface, and most of the stuff back here we don't need to preview. So I'll select all of this, middle click, and disable preview. And now that we've subdivided this one, well, we can do the same thing to the other one by copying this component, and we'll plug in this offset surface as the surface input. So technically, we've basically just applied the pattern to both of those surfaces. Now the one on the outside is going to be larger than the one on the inside, and that is because when you offset it, you're actually creating a larger area that you're subdividing. The inside one is going to be a wireframe. This outside one is going to be a panel, and I'll be creating a connection that connects those panels to this wireframe. So what I'll do first is bring in a component called deconstruct brep. And I'll plug in the panels into the brep, and I'll do the outside ones first. As you can see, we're now getting redundant surfaces. because every time we bring in a new component, it will preview that. And so sometimes it just starts overlapping. So I'll tend to disable the preview on the stuff before. This way it doesn't get in the way of the stuff that I'll be creating in the future, and you can always bring it back, right? So with this, we'll go to faces. Now we have, let's see how many faces we have here, 42 faces, and those 42 faces have an outside curve. Now if I bring in a curve component, this will actually give me the outside curve of each and one of those panels. How do I know that? When I select this and I middle click and bake, you can see that under the default layer, it baked each and every single one of these polylines, which is what we need to then offset and create that connection. So what I'll do is I'll go here and I'll just select all the stuff that I just baked and I'll delete it. Now in here, what we need to do is offset this curve. So what I'll do is I'll go to offset curve, and we'll offset this curve relative to the plane that it sits on. So let's go here to distance, because right now it's offsetting to the outside and we actually want it to offset to the inside. So we have to go to a negative component, and the distance will say 1.5. So now we've technically just, the good thing about this, and actually the important thing, is the faces, plug those into the plane. This way it's referencing the plane and it's offsetting it to the inside. So this is what we need to now extract the points. And the points are critical because those are the points that will be connected to this outside location on the wireframe. So now let's disable the preview on which ones? On these curves. And next, we'll bring in the component called discontinuity. So I'll go here. Discontinuity, what it'll do is it'll take a line, and wherever it's discontinued, which means that if this is a polyline, it'll give you a point, one here, one here, and one here. Basically, wherever the line turns, you get a point. What that means is that these panels could now be connected from this wireframe below. So what we'll be seeing is something like this. Having these points connecting here, the ones in the middle here will connect to 1, 2, 3, 4, 5, 6, and so on. So let's go and do the same thing that we did here, but we won't have to offset it to this inside surface. For these inside surfaces, we'll just be bringing in a deconstruct brep. I'll also be bringing in, now that we have this, we'll do the same thing basically. Bring in the curve component into the faces. Now instead of offsetting it, we'll be bringing in discontinuity. And once we bring in discontinuity, we have to plug in these points here. So to connect them, we'll bring in a line component. We'll start here and end here. So as you can see, what we've done is we have offset this to the inside and connected that line here, and offset to the inside, I've connected that line there. So I know it was probably a little bit confusing there, but that's all we did. So let's go back here, disable the preview on most of the stuff, and then get rid of the points. I'll select those, middle click, disable preview, and then do the same thing here. We'll bring back those panels. Okay. So at this point, we've basically created the connections, created the base geometry. Now what I'm going to do is turn this inside one into just a wireframe. To do that, we'll take those panels, we'll join them using brep join, and the breps will flatten the input, and we'll bring in a component called brep edges. What this component will do is when we plug this in, it'll give us those curves. And the reason why we don't use the deconstructed ones is it's because when you see here, we have 126 edges, and that's because each panel has a line and they overlap. So technically you have two here, you have two here. So where you have one and another one meeting, you actually have two lines. And then here, when you look at the output, we only have about 60 curves. On here, we have like 126. So we have way too many down here. And using this, we can now disable the preview and bring in a pipe component. I'll go to caps, round, and plug in the naked and interior curves. Now we can also have a different size inside ones than to the outside ones by having two separate components, one for the outside and for the inside one, and then creating two separate sliders for the outside and one for the inside. The next part is going to be to create that connection right where this line intersects with that surface. To locate where those are on the panel, what I'll do is I'll take this line and intersect it and bring in the origin of the plane. So we'll go here to a vector. Here we have plane origin. And I'll bring in the surface, and the origin are going to be those points. So these endpoints now what's happening here is that this is coming in as a grafted list, and this is coming in as just a regular flattened list. So I actually have to use this base surface for it to work, because now we have the information coming in organized in the same way. So it will actually work. As you can see now, we have this point lining up exactly where that surface is. And we need that because we need to now, where those planes are located, we'll bring in a circle. We'll plug in a radius, so we'll say 1.500. This way I have a few decimal points to kind of play with here. Now I'll disable the preview on the plane, and we're able to see a little bit more clearly where those are located. Now we are going to take those and subtract them from the panels. I'll actually go here to region difference, bring in curves A, which are going to be these faces. Curves B are going to be these circles. So we've now created the new panels that have that panel void. So we'll go here to boundary surfaces and disable the preview on this stuff. Now what I'll do is where those circles are located, I'll bring in boundary surfaces, which means it will create a surface at the boundary of that circle and extrude it perpendicular to that surface. So we'll go here to extrude. We'll extrude the surfaceness. And the direction is going to be using amplitude. So perpendicular to the surface, and it's offsetting to the inside, which is fine. But we also want to extrude it to the outside. So we have another one. So we'll go here, create another copy, and bring in a negative component. We have it extruding to the inside and to the outside, and the amplitude will be the value. So we'll do 0.5. And both of these outputs, I like to bring them out as one single output, and if possible, grouped, because there's so many and you'd rather have them grouped. So I'll flatten the output for the group, so when you bake this, it's going to be a lot easier. I'm just playing with the values here. And I'm disabling the preview and all that stuff, so all I see is this last component. And I'll also disable the preview on this one, because technically this is the only one that we need. So what's really cool about this, and I get super excited when I get to this point, because there are other things that kind of pop up into my mind, like how this is technically a truncation, right? How you're playing not just with the base geometry that we had as triangles, but now the new offsets kind of create this new type of geometry that is really fun. And I feel like there are other options here. Now we're only connecting the panels, so the panels themselves could have a pattern within it using this base offset. But even using this base offset, we can offset this a little bit more and create like glass panel that has openings and have that be transparent, have transparency. So like I'm saying, this is just kind of the beginning. When you start working on a script, you start coming up with so many different ideas. I'll disable the preview on this stuff. We'll go back to this curve, and now let's turn those into pipes. So we'll just copy this, holding down Alt, and then I'll just plug this in, which will give those, and that should work. Now, I actually feel like it looks pretty cool when it has that bump there, because it looks like a rivet or some kind of detail that it has. But I feel like this should be like a 0.3, you know, way thinner than this, and then the outside would be the thinnest one, right? And then I'll pull this one back a bit. And really the tolerance here is going to be which ones will get the closest. We see that there's a limit to how little we can offset. That's getting to like 1, and it's going to be like a ratio between the radius of that circle and how far you can get that and how close you can get that in. Because if we go here to our circle and we lower to like 0.6, can then probably get a lower value, maybe 1. And the offset here determines how far from the base structure here. I do want to create some panel openings, so let's go here down to this offset. We're going to offset it again. So we'll copy these. Basically, we can plug in the same value. This way, it's a lot, it's kind of tied to that. Obviously, we can add more, but we don't want to do less than this. So if we wanted to add more, we'll bring an addition and we'll say 1.5. So notice now that we can say like this is the minimum, and then it can go from there. And the thing is that since we have these panels, which are called, these triangular panels that are small, these are actually going to be our limit, because when I offset this further, at some point, the ones that will break before anything will be the small ones. So that's going to be our limit, but it doesn't matter, because now with this, we can take this offset and change. So either we can fill it using a different component, or here under corners, if we go here, I think round, that's the thing, that's if we're offsetting it to the outside. So on this one, I will go to a fillet edge or a fillet, and then we'll change the radius to 1.5. And with this, we will go to region difference, and this will be curves B, and this will be curves A. Surface A, curves B. This one's giving us some issues here. I think this one is the one that does it, and it's because it has to be before we turned it into a surface here. So we will actually use this after the fact. Now that we have these offsets, I'm trying to think what would be bring in boundary surfaces here. And so you can probably see that these, we could probably change the size of them using an attractor point or an attractor curve. But I think with this, it shows you the power of what this script can do, which is turn any surface into a panelized object like this. Now let's go here and bring in, change this value from 53 to a straight one. You'll see that it'll also work. So this will work on any surface, make overhang 0. Or even if we create it ourselves. Let's go here to, I think you guys will like this one. We'll go to a sphere, radius 50. We'll bring in isotrim. Or actually, we already have the surface. So it applies it to the sphere, to the inside. And if we want the surface to offset to the outside, well, we know that the value has to be +3. And then this one has to be positive. So there's a lot of things that actually happen when we use this sphere. Let's see if we can flip. It doesn't do it. Okay, so there are some limitations, like that sphere may not work. We'll go here into elevation view and create an arc like this. I'll extrude it out. We'll go to extrude curve. Select this and go here to set one surface. I was trying to create that base surface, but the surface is small, so when I created that other one that was so large, it did not work. So let's create it again. I'll go here and I'll create an arc. Starting anywhere here. I'll take this arc and we'll extrude curve by whatever amount this way. Now we can set one surface. I flipped it to the other way and now it works. Now let's increase the subdivisions. And it works perfectly. So I will take this and I will actually work off of this. So I'll bake all of the items here. And so we'll start one at a time. I'll go here to my layers, start a new layer and call this structure 1. I'll hit tab, type in structure 2, and hit tab, do connection, and then tab, panel 1, and then tab, panel 2. We'll start here. I'll make structure 1 my current layer and go to these two pipes. I'll middle click and bake. I'll go to structure 2, then I'll go to these connecting pipes, middle click and bake. Then I'll go to connection, which will be the extrusion, middle click and bake. Then we'll go to the panels, middle click and bake. and then we'll go to panels 2 and then also bake that. We'll go here to shaded mode, and I'll lock the default layer, which is the layer where I created that surface. This way I can take all of this and move it to the side. I'll type in zoom, selected. Cool, so now that we baked all of that stuff and we have everything else hidden, I'll select this, go to ZS for zoom selected, and I'll type in purge so I can get rid of all of the layers and stuff that I'm not using. So with this, let's go here into our Rhino mode. And let's take a look at our model. So everything is super clean here. The only thing is these panels are actually very, very thin. So this is where I'll go in to panels 1, right click, select objects, and type in join. This way it's a joined surface, and we can take that and go to offset surface, and then we'll offset it to the outside by 2 inches. Here's the thing, when you offset, it asks you if you want to delete the input. So I'll go here to copy to clipboard, I'll undo it, and this way I'll offset surface F for flip direction and do it again that amount. But this time, since I had copied it, I can now paste it because I had it on the clipboard. Now we can we have the outside panels, inside panels, and we'll go to panels 2, select objects, and do the same thing here. So we'll go to offset surface, we'll go to 1 inch, and so we'll do less for the inside panels. The next thing is connecting this to something, right? Typically these would have like a foundation. So to do that, we'd have to think of where the base line of this is. And technically we don't have that because we haven't baked that information. So one thing to keep in mind is also to bring in some of the base geometry of that we had before we created this dome. This way we can use that as a reference to create further geometry when we're modeling it here. So one trick to do is bring in a plane. I'll go to a new layer and create a plane from this endpoint all the way out like this, and then using these scripts, scaling it so it intersects it. Next thing is bring in a component called intersect, or a command called intersect two sets. We'll use this surface, then I'll right click on structure 1, go to select objects, and then enter. When you use that those two commands, it's going to ask you first set, second set, and it will give you a curve that is intersecting with that surface. Now we can also do this inside a Grasshopper, but this is something that is not necessarily, doesn't necessarily have to be in Grasshopper, because the idea is that Grasshopper takes care of kind of the heavy load of the programmed stuff, and then we can use some of our modeling skills to further kind of finish detailing some of the things here. So I'll select this and I'll type in isolate. This way I don't see anything else, I only see this, and I can go to top view and work with this. So I'll delete this information in here. Because those are not necessary. I thought I can select them all at once, but I could not. There are different ways to approach this next portion. I was going to use Well, that is on layer 6, which I will turn into a gray layer. Then I'll go to a new layer 7 and turn this into a red layer. This way I can get the midpoint. Now I typically don't have nearest on, and Smart Track sometimes gets in the way. I'll take this and I'll offset 2 inches to the right. I'll do 3 inches to the right, 3 inches this way. Two inches this way. And extend these lines and trim this out. Why? Because this is the location of where that connection would go. And if we can't see it, it's because I have it the same color as the grid. So this is a connection. If I bring in the structure, we see that it's intersecting here, and I'll extrude curve up to more than that. So I could be as simple as taking this and then doing Boolean difference to the inside to create a connection, but I feel like a good way to fix that would be to take this, I'll type in isolate, explode, and get rid of all this. We can join this and offset surface, flip direction, and do 1 inch. This will give us, by extruding this surface out and extruding this surface out, and in the middle of here we'll add a bit of detail. More detail can obviously be added to this, but sometimes working from the general form is the way to go. So we'll go and I'll also turn this into a block. I'll select this, type in block, we'll select this one, and we'll call this anchor. Because technically this would go down into the ground and be bolted down, right? So let's type in show, and let's go here to layer 7, connection. It won't let me change the name because of the block. So we'll go here, and if this is the center, which it is from the midpoint, then we can copy these at a specific spacing. So we can say every 2 feet, maybe a little bit more. And I'm holding down Alt, clicking, and it'll remember the amount. I'm just taking these using a mirror command. They look a little small, but that is because this is actually a super big structure. So with that, let's hide this ground plane. I'll bring back this curve, and I will offset this to make sure that it encompasses the outside here. So I'll go to offset, 2 feet. And I'll do the same thing out here. So let me show you a trick that I use. I'll go to offset to the outside. I'll select this one and use bounding box, which will create a rectangle at those extents. So I can just delete that and take this and extrude this down. So I could either extrude this down into a little stem wall or offset by 3 inches to the outside. Then bring this down minus 2 feet, minus 1 foot. This way we can loft these two and type in cap. So then turning that into a solid and then extruding this bottom surface down. Maybe by an entire floor. Either way, this would be like without a person, you couldn't really tell the scale anyway. So this might as well be, you know, 6 inches and this be 10 feet tall, or this could be, you know, really, really large. So that's that stem wall here. And then we'll use the center line to offset for a footing. So we'll offset 4 feet to this way, 4 feet this way. We can loft these, we could extrude it, different ways of doing it, and then extrude surface. So this is going to be footing. Then change object to layer. I'll have this side and this side overhang. And in terms of footings, you don't have to have a continuous footing. You could technically have this be a few separate footings, but I feel like it looks best when we have this continuous wall here. So these will be blocks. So I'll group those and copy them. Here's the thing. It's pretty tricky to move this relative to the center. So I'll go here to zoom selected and copy relative to that center. So I'll go to copy. I'll turn on project, because I'm not referencing a point that will be the same in the next location. But if I use project, I'll use the construction plane on the ground as my reference, and it will project to the middle, making sure that it always works here. The other way is selecting that, typing in MI for mirror, and then reflecting that using that mid location. I'll go to layer 7, select objects, and use the mirror command through the middle here. So projected end. Here's the thing, you do want to get close in there and make sure that it is projecting off of the location that you're trying to do it. Otherwise, you'll have a bit of a harder time. So I'll select these and do the same thing. Now in terms of how this would stand up, the footings would hold it up for the most part. This arc is going to try to push to the outside, so there may be some other engineering to do here, but if you were to put a slab on top, the slab would be poured on top of this one to this side and up from the ground there. So that looks a little bit small, but in reality, let's say if this was a outdoor design, the slab would be poured on top, something like this, and there would be sand and gravel down here, compacted. So that kind of covers, for the most part, some of the detailing in here. What I would want to do next is go here into rendered mode and apply some materials to the different components, because we have the structure, we have the connections, we have two separate panels. So it'd be cool to explore kind of the contrast between those two. The approach I'll take for this is going to be using V-Ray. Now you don't necessarily have to use V-Ray because Rhino already has some materials that you could apply. So you take similar steps just using your own materials inside of Rhino. So I'll go here inside of V-Ray, I'll just create a new material and I'll call this structure 1 or structure. And this one I want to create first because then I'm going to duplicate it. And when I duplicate it, I don't want to have to do these steps again. I'll go here to color, make it a very light gray. Metalness, I'll go to the top, and then roughness, I'll just do about 0.2. I will take that material and apply it to structure 1. And as we can see, it's already starting to apply some of the materials to the model. We'll go here to structure 1, duplicate, make this maybe a little bit darker. We'll apply this. Well, the structure 1 is going, the structure is going to be on structure 1 and structure 2, and this one will go under the connections. It could be a bit darker for that. And then the panels here will be, trying to think of what's going to be. Okay. I'll just create a generic material, call this panel 1. And then I'll create a new material, or I'll work off of this one. I'll go to a bit of a darker color. The roughness, I want it to be not super rough, but enough where you can see a little bit of shine. And I'll apply this to panel 1 and duplicate this panel 1. Go a tiny bit darker and apply that to panel 2. Or vice versa, right? You can say apply panel 1 and you can also create another material that is a bit more translucent. Use that as the panel 2. Here's the thing, opacity is not going to show up under this preview. So the last one that we'll use is create the concrete for the ground and for the footings and everything. We'll go here to our materials and basically copy panel 1 or panel 2. So we'll just copy panel 2, duplicate, and we'll bring this to a light gray. Our panel 3 is going to be our foundation or footing material. What I'll be doing is doing a quick render. Let's take a look at what it looks like here. But first, let me actually save the file. I don't want to lose all the work we've done. So I'll pause and I'll save both of these files under whatever folder. So I'll actually change. I have a preset that I've created called render 2, and this will give me an idea of what it's going to look like. And if I go here to V-Ray Interactive, I'll be able to see a preview of what my render is going to look like. And typically I want it to be facing the location of where the white background is, because this is a studio setup background. And I can change my aperture if I want to. I'll go, so if this looks good, which I feel like it looks pretty good, I'll now go and disable that, and I'll go to regular render. So now I'll leave this rendering and also capture this script. This way I can kind of create a little composite and create a library of the work that I do. And that's one of the things that I like to do, is share some of the scripts that I have and share some of the knowledge to get people into parametric architecture, because I feel like it's one of the things that is very critical to learn to become a better designer. So thank you very much for watching, and I hope to see you next time.